I'm Nick Ocello for Laufer Valve Technology. We are LIAG's wholly owned subsidiary and master distributor here in the United States. This is a valve breakdown and maintenance training. So this is a 1.5-inch three-way arc valve or shutter valve. You'll hear it both ways. You can kind of see the shutter here blocking one of our ports. Now, our valves are 3A approved for CIP, as well as having gone through the EHEG Class 1 cleanability test to prove that they actually do clean via CIP. One of the first things to talk about with our valve is that even if it were welded into place, you are able to pull all of the innards out of it while leaving it in the line. So like you can see here, we have a butt weld version of our valve. It also comes in tri-clamp. We have, Dean ends, beveled ends, stuff like that. So the first thing to do is to remove the 4 screws here at the top of the valve cap. Let's get them loosened. Now, one of the great things about the valve is that, someone that's experienced with it can pull it apart, do maintenance, and put it back together in roughly 5 minutes. Someone who's not familiar with the valve, maybe 10. They are very simple in their design, and that's the whole point. We don't want our customers killing 30 minutes to an hour per valve just to do maintenance on them. Additionally, we recommend after first installing one of our valves to check it after 6 months, see what kind of shape the O-rings are in and the shutter. And if they're still in good shape, then don't PM them. Leave the parts in. We use high quality wearing parts in order to extend the life and the uptime of the valve. So we've removed the 4 screws that were holding the valve cap together. The valve cap comes off. Now you have the valve cap here and you have the arc. That's the arc in arc valve. That's also what gives you the full bore of the pipeline going through the valve. So reducing things like water hammer and pressure drop, stuff like that. The next thing to do is to pull the arc and the axle out of the valve cap. So that pops out. You can see here there's an O-ring around the axle. That's the only moving O-ring inside of the valve. We'll also pull off the handle. There's just 2 bolts in the top. It's not too difficult. So you can also kind of see the inside of the valve cap. Now, inside of where the axle fits into the valve cap is a bearing bushing, typically made from POM. You can also make them in PTFE if you have like a high temperature application. You can kind of see it there. It's white. So just pop out the bushing. That is one of the wearing parts on our valve. You can now pull out the shutter. That's the second wearing part. And then we will put the valve on its side. We have a brass set screw here on the what we call the pinching nut. Loosen up the set screw. And sometimes you can unscrew these by hand. Sometimes the tolerances are a bit tight, so you want to use a pin spanner wrench to fit into the 2 holes at the bottom of the pinching nut there to unscrew or screw it. So we found our shutter, our bearing bushing, our dynamic O-ring, which we're gonna pop off the axle here. I'm also going to just set up a paper towel so we're not getting food grade lubrication. It's potentially hard to see here, but there's an O-ring down on the inside of where the pinching nut fits into the valve. That is simple to pop out. That's our fourth wearing part. And the fifth wearing part is the O-ring on the inside of the valve cap. Again, simple to pop out. Our valves have only 5 wearing parts. They are fairly simple. And again, check them after about 6 months. We have end users who replace them every quarter. We have end users that wait years. And frankly, it depends on what the application is. Our valves are used in a number of different industries, from food and dairy production, personal care items, to things like agricultural chemicals and paint. Anything that is thick, viscous, oily, sticky, our valves are made specifically for those kinds of things. So we're going to put the valve back together. The first thing you want to do is lubricate your O-rings. We recommend Kluber Paraleak. It is a fully synthetic lubrication. One note is to never use petroleum or hydrocarbon-based lubricants on your elastomers in our valves. Our elastomers, our O-rings, come in EPDM, Viton, or FEP. They will react very poorly to things like mineral oil-based lubricants. They'll get broken down. They will stick and swell over time. It's not a good idea. So the Kluber is good. Haynes is an American brand. That also works really well as a lubricant for our O-rings. So once your O-rings have been lubricated, put them back inside the valve. We'll start here with the pinching nut. And that pops in nicely. Move on to the axle O-ring. Fit that around. And then lastly, the valve cap O-ring. One thing you may want to do is lubricate the inside and the outside of the bushing, which I'll do now, just to help things move around in there and to keep our valves easy to turn. There we go. So pop the bushing back into the valve cap. Pop the axle back into the valve cap. And there's a little, sometimes a click, or there's a sound that you can hear when that O-ring clears the inside of the valve cap. That's how you know it's actually seated in place. So for a valve cap put back together, we're going to put the pinching nut back in. There we go. Now, when this is getting screwed back on, you can actually feel as the pinching nut is getting close to that O-ring. You want to screw it in just past the O-ring. Doesn't need to go far. Put in your shutter. And then fit the valve cap back on. Now, one of the things you may notice is that there is a larger gap here on the back side than there is on the front where the shutter is. That is by design. There's actually some tension due to the arc. So one of the other things that the arc does, aside from give you the full bore of your pipeline and allow our pigs to go through, is it pushes the shutter around on the inside of the valve. It just uses pressure and friction. There's no mechanical lock, so no extra places for bacteria to get in and hide and grow. Another thing that you'll notice about the inside of the valve is that there are no dead pockets on the inside. Again, there's nowhere for bacteria to hide and grow. So we'll get this put back together. Line up the holes for the bolts. Screw them down, and then we'll add our handle, and that's that for valve maintenance. Like I said, very straightforward, very quick. even with an explanation, this only took about maybe 12, 15 minutes. Put this back together. And we'll give everything a quick tighten down. And we're good. And that is the basics of shutter valve or arc valve maintenance training. It's a simple valve. A lot of the benefit is in the design. And there we go. You can see even when it's not actually, sorry, my hands are a little greasy. Even when it's not welded into place, it's easy to turn. So once you have the valve cap bolted back on and the handle back on, you give it a couple turns, and you take the pinching nut and you turn it another 45 degrees, and that's it. And what that does is the pinching nut acts as a guide for the arc to move around. If you have problems with back pressure, you can tighten that a little bit more, and that'll increase the stress on the shutter, seating it more firmly into the port. Over tightening that can lead to galling of the stainless steel of the axle. So try not to over tighten it. And that's it. Thank you.